Okay, so now guys, now in this video we have to find dy by dx if x is equal to a cos t plus sin t and y is equal to a sin t minus t cos t. So we can clearly see that we have to move towards the chain rule differentiation because we have the parametric equations. We have x and y, these are the two variables, and then we have t, then which means that t is the third variable. Now remember, the letters a, b, c are always constant whenever we are trying to find the differentiation of anything. Okay, so a is the constant, so we have to find dy by dx. Okay, so the chain rule would be like dy by d multiplied by d by dx. Okay, so these are all the predefined variables x and y, and what is the third variable? T. So we have to find the derivative of y with respect to t and then the derivative of t with respect to x. So how can we do this? First of all, let's just take into the consideration this y equation. So we can apply differentials on both sides of the equation. Dy by dt, d by dt a sin t minus t cos t. Okay, a is the constant, it would be separated, then we are left with d by dt sin t. We can just separate the differentials on both of these equations. So d by, and these are under a bracket. So a, we can see that the derivative of sin t is actually cos t. Okay, and then the derivative of the angle d by dt t minus this will actually obey the product rule. So what the product rule says is that if you're having two functions d by dx, fx and gx, so you can actually multiply these two functions by such an equation. Okay, plus the second function multiplied by the derivative of the first function. So this is actually the rule. The first function as it is multiplied by the derivative of the second function plus the second function as it is multiplied by the derivative of the second function. So over here fx would be my t, which is the first function, and the cos t would be my gx, which is the second function. Let's just use a bracket over here so that it just separates those things, because we are having a negative sign, it is going to cause problems. Fx as it is multiplied by the derivative of gx. What is gx? That is cos t, plus gx as it is, which means that cos t would be left unturned, multiplied by the derivative of the first function, which is t. A, then we have cos t, this would be cancelled, minus t multiplied by the derivative of cos t is actually negative sin t plus cos t, and this would be the same thing which we did over here. So the brackets close, and now we can actually multiply this negative sign over here. So a cos t minus, and this minus would be positive, t sin t minus cos t, and yep, that's it. Then we can move towards the second part, and that is dt by dx. So we have x is equal to a cos t plus sin t. So we can apply differentials on both sides of the equation. D by dt, d by dt, a cos t plus sin t. So let's just separate the differentials. D by dt, a cos t plus d by dt, sin t. Then a is a constant, so it would be left as it is, d by dt cos t plus d by dt sin t. The derivative of cos t is actually negative sin t, plus the derivative of sin t is actually cos t. Okay, so this is the final derivative, and now let's just put these things into the chain rule. So the chain rule was dy by dx is equal to dy by dt multiplied by dt divided by dx. So let's just put these values. Okay, so these are the values which I just placed them over here from the result which we calculated. So the question actually said that you have to find dy by dx, right? If you see cos t minus cos t, so these would be cancelled. We are left with a t sin t. Okay, so there is a problem over here. We found dx by dt, but the derivative, the chain rule was actually saying that you have to put dt by dx. Okay, so we have to put the reciprocal of this thing, and we have done this thing a couple of times before, so you can watch my previous videos if you're unsure that what I'm doing over here. So we will have 1 over negative a sin t plus cos t. So we are left with a t sin t multiplied by 1 divided by negative a sin t plus cos t. Okay, so we have a t sin t divided by negative a sin t plus cos. We can separate the denominator, so we have a t sin t divided by negative a sin t plus a t sin t divided by cos t. Okay, so I just separated these denominators. So a is cancelled and sin t is cancelled, so we are left with negative t plus sin t divided by cos t is actually tangent t. So we have a t tangent t. So this is the final dy by dx of this equation.